go. So the title of my talk is Nextflow, Kubernetes, and DRAGENs. Oh my, because there's a lot of stuff going on here, and I'll talk about how we've integrated these things. So the agenda first, I give there's a little bit of background just to give you to understand like what the domain we're working in and why we made some of the decisions we did, and then I talk about the actual integration. So first, NovaSeqDX. So we're talking about in vitro diagnostics here. If anyone's not familiar, that's basically given a tissue sample or blood sample, we make a clinical diagnosis based on that. So something like, do you have cancer? Maybe what kind of cancer? Do you have a rare disease? There's all sorts of things. Anytime you go to a doctor and they draw your blood, this is what's happening. You're getting a diagnostic test. So devices like our sequencers that are designed for IVD operate in a much more highly regulated environment. So there's high thresholds for documentation and testing that a normal research device wouldn't necessarily have. And this is good, right? Your life depends on the results of this diagnosis, so you don't want just some random stuff to come at you. And importantly, and this is why Illumina and lots of other companies are interested in IVD, is that these tests cost money. Insurance companies will pay for them, and so we can make money that way. We already have two sequencers, the NovaSeqDX and the NextFlow, and we have several diagnostic tests that we sell. The Illumina COVID-Seq test, which I spent 6 weeks of my life living 12 to 15 hours days writing at the very beginning of the pandemic, which was exciting. And the TSO comprehensive IVD solution, which is a cancer diagnostic, and several other tests. But what about our biggest sequencers? We don't have an IVD solution for that yet. And so that's where the NovaSeq6000DX comes in. The NovaSeq6000 was our biggest sequencer. It was the sequencer that gave us the $1,000 genome. It's since been replaced as of last week, I think, by the NovaSeq Series X, which will ultimately give us the $200 genome. But NovaSeq6000 is the one that we're taking DX right now. The problem is NovaSeq6000 only outputs sequence. Right, so it's just the ACGT of your DNA. And that's not enough for a diagnosis, right? You given a big FASTA file, what are you gonna do with it? Not much. So you have to actually analyze those sequences. And unfortunately, the NovaSeq does not have any additional onboard compute. The engineering team has optimized the compute on there to do primary analysis and get the sequence, but that's it. You can't do anything else on that machine. So what we're going to do is pair a NovaSeq6000 with a DRAGEN server. And I'll talk a little bit more about what a DRAGEN server is. But DRAGEN is where we're going to run the analysis and do all the extra things that we're going to do. So analysis implies workflows, and workflows implies Nextflow. And this is really because our customers demand it. Illumina has experience with lots of different workflow languages, and Nextflow is, at this point, clearly rising to the top. And so our goal for this instrument is not to just provide one or two tests that are hard-coded into the machine, but to allow multiple arbitrary workflows. And ideally, this workflow should be able to run in our cloud system in addition to on the sequencer, because we don't want to have to write, do the same testing and validation more than once. And eventually, we'd like to open this up to third parties, right? We want our collaborators to work with us to deliver their solutions on our platform. That way, everybody gets to make money. And so the system that ties all this together is called EdgeOS. That's just the internal name of the system. Because we're doing this on premises, it's the edge, at least with respect to the cloud team we work with. And it's not an operating system, but that's the name we chose. So this is the platform we use for integrating all these services. Right now, it's a collection of about 20 different microservices that run on the Dragon server. It provides things like Postgres, Rabbit, Keycloak. It provides UIs for doing all the run planning, sample sheet import, analysis planning, and then full run management. And what's nice about this is that it's the UI now becomes accessible remotely, which wasn't possible before, so you don't actually have to walk up to the sequencer and see what's going on. You can sit at your desk and monitor things. I mean, you still need to go to the sequencer to load it, but monitoring at least can happen remotely. And this is a picture. This is what our new Dragon servers actually looked like. They're not actually branded Illumina yet, but they're pretty nice machines. And so I'm trying to, with this section, I'm trying to illustrate why we made the decisions that we did. So Dragon, which is called the Bio-IT platform, it's basically a normal server. It's a pretty big server, but it has an FPGA. And so if you're not familiar, FPGAs are kind of like GPUs. It's hardware-like acceleration, but they're dynamically reconfigurable, right? So you can configure the FPGA for some particular process that you want to run. So for instance, you could have a bunch of zip cores loaded onto the FPGA. So if you're doing a lot of compression or decompression, you can optimize for that. Whereas if you want to do a bunch of sequence alignment, you can put some Smith-Waterman cores on there. And you can change that as you're running. They're also low power, which are at least relative to GPUs, which isn't relevant so much for our platform, but when this FPGA is integrated into a sequencer like it is on the NextSeq 1000, 2000, and the NovaSeq Series X, you don't want a high power computer sitting in that box on your desk or in the next to your desk that is putting out a lot of heat, potentially impacting the actual sequencing chemistry. And you also want to be able to plug it into the wall without having a special power supply. So low power is a really nice feature. Using Dragon is not necessarily for the faint of heart. As it's delivered now, if you were to go buy a Dragon server from Illumina, you just get a command line interface, and it can be challenging. So some of the key things that we need to pay attention to, only one Dragon process can run at a time, right? Because if you go back to the dynamically reconfigurable part, you don't want two processes trying to reconfigure the FPGA at the same time, because then you get the hardware into a funky state and bad things happen. You obviously need access to the hardware. So when we talk about containers, that's a big consideration. And then for our particular server, there's a requirement that the version of Dragon running in the container must match what's running in the OS. And this is because of how we've configured the server. I've got to say AWS has done a much nicer job with their F1s. Don't have that same restriction. But for us, that's what we have to deal with. Okay, so integrating Nextflow. So the goal is to be a normal Nextflow environment. We don't want to put a lot of special restrictions on you or make it hard for the developer. There should be pretty minimal overhead to use these features. And so what we've done is there's an optional Dragon label. So if you're going to use the Dragon server or the FPGA, you need to use this Dragon label, a process selector. You need to specify the right container. And then when Illumina, or when we launch the process, or the workflow, sorry, in your params object, you get an Illumina block that has a bunch of default values. That's where you'll get all the run ID, path to the sample sheet, all this kind of things that are standard for every Illumina run. And that'll just come to you by default. You can still add your own parameters, of course, but that's what we give you by default. So we wrap all these workflows in an app, and it consists of, there's the workflow definition, any workflow configuration that you need, any resources you need for the genome, or for the workflow, so genomes, bed files, whatever you need to do your analysis. There's sequencing run definitions and kit definitions that are needed by, for planning a run. You can define your own custom parameters, and then there's a UI definition, and those two are actually mixed together, the UI and the params. It's very similar to the NF core schema idea, right? And that's an app. And so Kubernetes, first of all, on premises, why are you doing that? So we have a lot of customers who either can't or won't use the cloud. For all the arguments that you might have that no, you could do it in the cloud, sure, but they're still saying no, and we want to make those people happy. And it's still a significant amount of our business. And then Kubernetes. Why are you running Kubernetes? We have one Dragon server. What do you need Kubernetes for? So the solution to most of our performance problems is just add another server, right? We have really tight time restrictions on the sequencer. So a workflow needs to finish before the next sequencing run happens, because sequencing runs are really expensive, and you don't want to potentially impact that sequencing run because you are running some unoptimized code somewhere, right? So analysis needs to happen, and so if there's ever a time when we need this analysis, but we also need it faster, we're going to plug another server in. I like containers, and this is a nice way to deal with containers. And our design called for a bunch of, it was a microservice-based design, and Kubernetes. I'm not sure how many people are familiar with Kubernetes. It's a container orchestration environment made for distributed systems, runs containers really nicely. Generally, it's big clusters in the cloud, but we're running it, with a nice lightweight distribution called K3s, which is really simple. You don't need, complicated etcd database or multiple nodes. You just have one single SQLite database to keep track of everything. And so that's why we went with Kubernetes. And now this is how we tie it all together. So remember, the key requirement for Dragon is only one process at a time. And if you're talking about Kubernetes, which is all about parallel distributed, and you're talking about Nextflow, which is all about parallel, that can be a challenge. So the way we handle this is to treat Dragon as a system resource, right? Just like you have CPU or memory resources available to you, we treat the Dragon FPGA as a resource. And Kubernetes has a nice plugin system for this, the device plugin. And so we wrote one for Dragon. And so this is what it looks like. This is a basic pod spec. This is the definition of like one container that runs in Kubernetes, right? This is a very basic definition. And so what we do is we add a resource limit, right? We've created a new resource type, that Dragon FPGA, and we've added it as a limit to our process definition or pod definition. You can also have limits in there on memory and CPU and things like that, but this is what we've done for Dragon. And then what we do too is we add a label. This is just metadata that's added to the pod that runs. And when I say pod, I mean a container. They're basically the same thing. Pod's just the Kubernetes vernacular for that. And so this labels it and says, hey, this is something we care about, and we're going to use Dragon version 4.01 here. And so we'll tie that in a minute. So that's Dragon on Kubernetes. And if I was just running Dragon, not worrying about Nextflow, this is all I'd have to do. There's a bunch more stuff that would go into this pod spec, but this is basically it. So now Nextflow on Kubernetes. Nextflow has a nice Kubernetes executor. We launch Nextflow main in its own pod, so it gets its very own container. And then that pod launches subsequent pods, which are the individual task processes or process tasks. And then we have a lot of special policies and permissions set so that you can't do anything really nefarious. We try and lock that environment down so that, because ultimately we'll run third-party code on this trusted platform. We need to protect ourselves. And so Nextflow has some configuration syntax that supports a subset of what Kubernetes needs. And so this is kind of what it looks like. Given a pod, we define a bunch of volumes. So this is the data. This is how it accesses the data that, that we need to analyze. And you can see there's some interesting things here. So we mount these things as read-only or possibly read-only. So we have tight control. Like, for instance, we don't need to be able to write to the workflow directory itself. We want to protect that so it never gets overwritten. And then we can be very parsimonious about what we mount, right? We don't mount any old analysis on the system. We mount specific directories that have the sequence data for this particular run. And then we put this in a process selector to make it easy to use, because we don't want, we can't ask a workflow author to have to know all the volumes that we need to put in place for a particular process. Then we add the label. This is where the label comes in. And we add an accelerator. And this is not part of Kubernetes. It's just a normal Nextflow directive. But this is where we add that accelerator directive. And so this is all wrapped in in the process selector, so it's easy for the developers to use. They just say label Dragon 401. We're not done. So we still need to ensure that the version of Dragon installed on the OS is the same as the one that is running in the pod. And then we also need to give Dragon a bunch of special privileges. So we need to set host IPC true for all the shared memory needs, host PID so it can talk to the license manager correctly, modify capabilities and configure huge pages, all this really messy stuff that nobody should need to deal with. And you can't do that through Nextflow. The Nextflow syntax for Kubernetes is deliberately limited, and I think that's a really good thing. Nextflow shouldn't have to reflect all of the stuff that goes on in Kubernetes. So what do? First, we've implemented this thing called Dragon Manager. And this is a service running in the OS. It doesn't run in Kubernetes. And it provides a simple HTTP API for installing specific versions of Dragon, right? So you can just say, hey, I want to install this Dragon on this version of Dragon on the machine, and it will take care of it. It has further support for doing self-tests, getting the status of installations, managing licenses, doing a lot of stuff. And but the problem is, how do we tell Nextflow to tell Dragon Manager to install a particular version we need, right? Because we have a process running, it says, I need Dragon 401. How does it tell the server to do that? That's where mutating webhook admission controllers come in. And it's a mouthful, but it's some pretty cool magic. Basically, this is a feature that allows you to take a Kubernetes pod spec, and before Kubernetes actually launches it and says start running, it gets to mutate that pod spec and add do whatever you want to it to make it work the way you want. And this is really, it's pretty dangerous. This is not a normal thing you would do in Kubernetes, but it's pretty powerful. And so this is where the pod label comes in. This is what we key off of. The webhook, it looks to see any pod that comes through that we ask Kubernetes to start, does it have this label? And if it does, we mutate the pod spec, right? So we include all the pod settings that we need, all the host PID, host IPC, all that kind of stuff. It injects an init container into the pod. And init containers are a Kubernetes feature that basically tells you to run this pod or this command before I run the main pod, before I run the main container. So before you run this process, do this thing. And so we have the Dragon version switcher client, which hopefully the name makes sense, that we basically switch the version of Dragon. And that's what's talking to Dragon Manager. And so finally we have a pod, and actually the title should be finally we have a Dragon pod spec. So once we have a good pod spec, Kubernetes starts running, but what it first does is it waits until this resource is available, right? So this is where we block, this is where we make sure that only one version of Dragon is running at a time. And then once the FPGA is available, the init container starts, and this is what talks to Dragon Manager and says, hey, I want you to install this specific version of Dragon, and it can do things like run a self-test or Dragon reset to make sure that everything is on the server is nicely configured, and it will block until Dragon Manager is complete. So the pod will just sit there in the init phase waiting for Dragon Manager to finish. And finally the pod starts and the process runs. And that was a mouthful, so hopefully I can illustrate this a little bit better, so we'll walk through this in an illustration. Okay, so this is, imagine the whole screen is a server. This is the one server. We have Kubernetes running on that server. Within Kubernetes, we've got 3 services. The workflow execution service, which is just what interfaces with the rest of our system to launch Nextflow. And we've got the Dragon admission controller, which is our mutating webhook. And then we've got the Dragon K8s device plugin. The admission controller is what does the mutation, and the device plugin is what mediates access to the FPGA. And then on the server outside of Kubernetes, we have Dragon Manager running. So this is kind of the normal state of our system. And then at some point, a request to run the analysis comes in. And that triggers Wes to launch Nextflow main. So it starts a new pod. So each of these orange rectangles is a pod running. It's a container running in Nextflow or in Kubernetes. From there, Nextflow main creates this pod spec, right? And so based on the process selector on the label, we've added, you can see we have the Dragon version label, and we have the resource limit, and that's the beginning, and that's what we do. So now this pod spec comes into the world, and before it gets anywhere, the Dragon admission controller says, oh, hey, you've labeled this Dragon, so what do? We mutate it, right? And so we take that pod spec and we add an init container that runs the Dragon version switcher client, and with this for the correct version, and then we add down below any of the additional Kubernetes parameters that we need. And there's a lot more there than just those. So now we get to the point where Kubernetes is actually going to run. But first, the device plugin is looking at this and says, hey, we don't have the resources available in the system, so we're going to wait until the FPGA is available. And then once that becomes available, we actually want to start the process, start the pod. And so that's where the init container runs. So init containers run before the normal container. And so this is where the Dragon version switcher client talks to the Dragon Manager. Dragon Manager installs the correct version of Dragon on the OS, and we wait for everything to complete. Once we're ready, then we actually launch the pod, and then your Nextflow process runs. And that's basically it. So I think I'm doing pretty good. I like to think that we've cleanly integrated these 2 things, Nextflow, Dragon, and Kubernetes. And we think it's a relatively seamless experience for app developers. All you really need to do is add that Dragon version label and make sure it matches what's in your container. If you don't, there'll be problems. And then what I haven't talked about but we can also have different versions of Dragon running in different processes. So you can have one workflow where you can have Dragon 3.9.5 running in one process and Dragon 4.1 in another process, and any kind of mix and match that you want. And this is really valuable because for IVD stuff, it takes a long time and is very expensive to validate these things. So if you have a validated workflow that runs on a particular version of Dragon, it's in our interest to be able to continue to run that. So being able to switch between versions of Dragon is a really nice feature. And then it's very flexible, so we'll be able to adapt to things in the future. And I think that's everything I have.
Thanks, Mike. So we have a question from Francisca. So will customers be able to run their own custom Nextflow analysis pipelines on the Dragon?
Not yet, but eventually. That's the goal, right? We want to get third-party developers involved, but again, this is only an IVD device, and whether we release this for RUO so that you could, in theory, load your own. So at this point, no, but eventually, yes.
And another question from Ben. So how do you provide reconfigurability to users, since it looks like they don't need to build their own FPGA binaries? How do users integrate the different FPGA codes into their workflow?
Yeah, I mean, so yeah, I should have had a slide that illustrates what a process is, but all you need to do is put the label Dragon 401, and that pulls everything into the Nextflow, it does all that configuration that we talk about. And Dragon handles all the FPGA configuration in Dragon Manager, so that all happens behind the scenes. So you really don't need to know anything about it. You just need to know the Dragon command line that you need, and you should be good to go.
Okay, thank you very much.
Thank you.